RSA, encryption, decryption algorithms, elliptical curve, digital signature. And in the meantime, I'm trying to solve the questions from midterm examination. So let's start. At first, I'm trying to start with cryptographic hash functions. Okay, as I said, there are two different for implementing and using different hashing algorithms. One is at first you must import the library, then you 56. So M will be a hashing object. Using this command, update hash, for example, here it's my name, but by putting a B before this string, I'm converting this byte. Then I can print the output. If I run the program, okay, this is the output hash of my name using SHA-256. I change it to 1. Again, if I run this, I have the output using SHA-1. I also in steps. For example, in the first step, I just put my name here. In the second, so in the first step, I just put my name. In the second step, I concatenate to and again here I can as you can see, the output is the same. Okay, I can do this in another way. You can change the type of this output of the hash from hexadecimal to byte by this command. This is hexadecimal. As you can see, this is the output of hash my name. This command bytes from hex, you can convert a hexadecimal to byte. Let's run it. As you can see, this part is exactly the same as this output, but this highlighted output is in hexadecimal format, but is in the byte format. Okay. If you want to use this library, okay, hashes dot the name of the algorithm SHA-256, or you can use SHA-1. Then again, using update command, you can put all the information you want to generate hashes. At the end, you must use finalize command to close the hash. Please note, while you are using this library, you don't need to use finalize, but if you are using this library, finalize bit output. If I run this, as you can see, the output, two parts is the same. As you can see here and here, this is the hash of my name. And copy, paste. If I run again, as you can see, if you print digest directly, the hash of my name will be printed, but in format. Okay. This command converts the byte format to hexadecimal format. So this is the hash of my name in hexadecimal format. Again, using this command, you can convert the hexadecimal to byte. As you can see, this part is exactly the same as this part. It means that when you print digest, the output is the same as when you convert this hexadecimal to byte. Both are the same. Okay? So here there are different examples that you can use different, you can put different information in each part, and that's it. So this is hashing. Okay? What's the difference? The difference is that the output, for example, when you use SHA-1, the output is 160 bits. In hexadecimal, it is 40 letters. If you count the number of letters in this output, it should be exactly 40. For example, SHA-256, the output, the length of the output will be 256 bits. In hexadecimal, you should divide it by 4. It makes 64 letters. So if you count the number output, it should be 64 letters. Okay, this is the as you know, the cryptographic hash functions. For each will have a different output. Hash function, it's a one-way function. It means that using the input you can find the output, but having output, it's not possible finding the input. Okay, name the hashing algorithm, we can find the output, but just using the output and the algorithm, the name of the algorithm, it's not possible to find the input. Okay, this is hashing, crypt hashing. Let me check the about hashing, I think. In the second midterm, in the second exam, you were asked to using the following hash algorithms, hash and copy paste the result in the answer box. SHA-1, SHA-256, and SHA. Simply, you can program. For example, this is my name and this is the output of SHA 256. You can change it to 512, run it again, and this is the output. Okay, so let's move to RSA encryption decryption algorithms. So RSA is one of the algorithms which is used for encryption and decryption, and also we can use it to create digital signatures. Okay, if you want to run these programs, if you want to use the RSA algorithm, you should use these libraries. Okay, RSA serialization and default backend. So in the first part, we should generate private keys and public keys. To generate private key using a command like this, RSA private key, with these parameters, we can simply generate a private key. So private key now is a private algorithm. You should serialize it. To serialize, you use the private and private byte. You can use two for to output PEM and DER. PEM is something like this, starting with these words begin RSA private key. But DER is a byte. Change it to DER. So this is DER, a private key in DER format. Okay. Oh, sorry. This is the DER format. It's a converted to byte. So usually PEM is more comfortable. Now to generate public keys, simply we use this command private key dot public key. So you can key, but also you can open a file and save the private key inside a file. This is the private key and this is the public key. Okay. So in the first term here, question 1, part A, using general public keys as a text. So you could simply run this program and copy paste these two parts onto your answer sheet. Okay, please note this part, the file with this name, you can change the name whatever you want, and this part save the public key in the file with this. Again, you can change the name of the file with everything you want. So we have generated key and the public key, but also we have printed them out and also saved them, both private keys, both private key and public key inside the file. Is the name of the file containing the private key, and .pm is the file name containing the public key. Okay, so this was the answer of the part A. Okay, Let's continue. But this part. Now, I want to encrypt some information using RSA. To do so, here you have a plain text message. Whatever you want to yes, the recording. Yeah, the recording is active. Here you should put everything you want to encrypt. For example, I want to encrypt my name here. Then I load my private key from a encryption. We need the public key. Here I have loaded the public key. Okay, I read the public key from that file, from this file. Then using this command, what is Alice public key is here. Alice public key dot encrypt, this command with these parameters. Ciphertext contains the encrypted message. Plain text message is exactly this message in the you were asked. So find here and come out this run. This is the encryption of my name using that public key. So let's check the question again. In part B, you were asked to encrypt your name and family using the generated private key in part A. Send the encrypted message as a text, not a picture. For example, so this is the encryption part, and for the decryption, use this part. No. For the encryption, we use this part. I should open the private key file. So sorry, this is the digital signature part. Let me find the. Yes, this is the encryption part. This is the encryption part. We should in the file containing the private key. Okay, as you can see, Alice private key will be the private key. Now, what is this? This is the encrypted message. Encrypted message here. So I copy and I paste it here. Okay. And now, if I decrypt it, you can see the original message, which was my name. So that was the encryption. This is the decryption. And let's talk about the creating digital signature using RSA. Digital. Let's me. This is the digital signature. You have a message here. you want to sign it, I think in the second examination. No. What was it in the first? Yes, you were asked to create a digital signature, but using I will explain this question in the easy part. Okay, so let's back. Creating digital signature using RSA. You have a message here. This part again from the file containing the private key. I load the private key, so this is my private key. This is the message I want generate the digital signature using this message. Okay, to create signature, this is my variable. I use this command. As you can see, this message is this. I want to signature based on this message. Other parts always are the same. We don't change any part. And finally, here I have printed out the signature, and this is the signature. And now how simply I copy the digital signature here, I put it here. In fact, I should convert it to byte format using bytes from hex command, using this command. So this is the signature created here. This is our message. Ali, I, Wahid, give you $2. This is exactly, I want to check that is exactly for this message or not. I want to verify that. To verify, you should use the public key. So public key is equal to Ali's private key, public key. This is the public key. So using public key dot verify, I verify this signature and this message always are the same. No output, so everything from the original message. And now if you see the message, this message is not as the same as the which signature was created. Put the dot in, and I use the digital signature. Digital signature prevents others to change the original. You have a message with others, you create is digital signature. So if others change messing the digital signatures, you can easily find that message. Okay, and this was the RSA private key, public key, encryption, decryption, and signature creation and verification. So now I think in the first examination now simply you can solve the first question. And the second and the third and the last part is elliptical curve. Okay. Again, we need some libraries. Okay. We have some functions here. This function simply takes a public key and returns its calculated SHA-1 hash. We know that says in different cryptocurrencies are hash keys. This function to a file name, okay? Load key, this function loads a private key from a file. So, in this question, you were asked, suppose data is equal to your name. This is now having private key seal to generate its digital signature. At first, the first step is I should save it beside my other files. Example. I paste the key here. I save it. Exam underline key.pem, and now by calling this function my private key, okay? To generate a key, simply call this function ec.generate private key, returns a private key. Then PM is the private key in the PM format. So if this is my private key. To create the public key from private key, simply use this command. A variable, then private key.public key. You can generate a private key here, as you can see. After printing out the key, I have saved that key, file name alireza underline key.pem. Save key. Okay. Then here I have serialized the public key. This PM format. This is DER format. This is printing out the. Here I have converted the public key in DER format to byte format. And here I have converted the DER format address to format a public key to an address. Okay. Till now I can answer this part. Which of the following transactions are not? This is the structure of transactions. It was a very, very simple question because this is sender hash. The first parameter is sender hash. The third, sender public key. In the previous, I emphasized that there is a relation between sender public key and sender addresses, valid address. Who knows what's the relation between public key and valid addresses? I will use. Don't worry, I will use. But answer me. What's public key and valid address? That's key is address. If you know this, simply solve this question, because this is sender hash. Okay. If you check the all transactions, sender public key is the same. You know, sender public key, all transactions are the same. Okay. How is it possible hash this public key but having different addresses? See here, with this address, definitely at most one of them can be right. Now I want to check that is the sender hash is generated from sender public key. Now I will upload the public key. This is the public key. Okay, this is the public key. I copy the using this command, using this command key, using this command. Okay, just command. Ignore the previous commands. Here I have converted this public key format, and after that, using calculate show on hash pop dir is this. I generate this as out the address. So this program answer this part. Ignore this part. Ignore this part. Just this. So I copy. Here. This is the answer. So check all the three transactions has such an address. A9A. Let me check. No, and no. That's it. All three transactions are invalid. Yeah. What if let me copy, for example, okay. Now how can I, if I exam, you could simply say the sender public key hash, so all the transactions are invalid, and that's it. Okay. And now I have checked the sender public key. I have generated its hash, and the generated hash is equal with this hash. What should I do? I should check information. What information I can check? Now nonce is not important. I will explain. This is here. Okay. Digit is calculated in this question. We don't have information for the digital signature because here you don't just this question. You could simply solve this question using these two fields. Okay, but for the second one here, I gave you the structure of No. I think digital signature transactions. Let me check. Signatures, digital signatures are recipient hash, amount, fee. So we can simply calculate digital signature by copy and pasting the information here. Recipient hash. Recipient hash. This is recipient hash. Okay. I will put amount. Amount 7. So I will put then fee. Fee is 4, so over here and put nonce is 1, so I put 1 here. D is which we. If I run this part, this is, and now I should verify it using this command. Before that, I load the public keys, the command that I used to I simply put it here. Now pop. Okay, where this is seek. D, what is D? D, this is data, our data. Let me to run. Okay. Byte, no attribute here. So sorry, let me public key verify. Public load. I should serialize it to a DER format. Let me to convert it to DER. Coding DER bytes. This is byte. And preloaded signature verified signature bytes from hex. Public key verify. Where is the public key? Public key, private key using. We don't have the public key. I think we could verify the signature. Let me check. Name error. Data. Here. D calculate signature. It's okay. Sign private sign. So using a private key. To be honest, we don't have the private key, so you cannot verify the digital signature. You know, if you want to check it, you should have the quest. Okay, so this question we cannot check the signature because here we need the private key. In this question, you don't have the private key. So the only thing that we can check is that we hash all these fields, this, and all these fields should be this transaction ID. As you know, the transaction ID is the hash of all fields. It means that we should use this command. We should use this function, something like this. I should put the information here. For example, I should copy this here. Then put other fields there. Run this part. The output is this output be as the same as this one. Not the section. Okay, for checking the signature, we need the private key. Since in this question we don't have private key, so we cannot check the signature. But just we can check two things: check public and has to be consistent as I checked, and finally can the hash of all the fields and then check that the output is the same as transaction ID. If it's not, okay. If it's not, it means that the transaction is not valid. But in the examination, you can simply check the sender public key and sender hash, because in all the transactions we have used just one public key, and one public key, it's not possible to have three different hashes. So it could be true, but as you can see, all three was invalid. All three were invalid. Okay, let me use to solve this part. No, sorry. This question. I want to generate a digital ask your question. Yes, we have all the codes are here. This is a code for saving public key, or this is a code for saving public key. This is a code for loading the private key. If you can load a private key, then using a command here, you can see I have saved the private key. Then using this simple command, you can calculate its public key. So we have the code for saving the keys. Or for the public key, you can rewrite this function. Okay. Instead of private key write, simply write public key. And that's it. Execute what? Which question do you mean? Now I'm trying to solve this question. I want to solve this question. Here there is a private key, okay? As I explained, I saved that PM, and now using by calling this function, file name exam key dot okay. So now private exam key is using I should use this command. Okay, so I'll copy this here. My data, so D is be my name as the question asks. That's it. Okay, so the answer of okay. So 1, 2, 3, all 3 questions answered. Last question in a transaction like the previous question was the application of nouns, as you have to distinguish between with the same recipient and sender. When the sender and the recipient and all the data like the amount, fee, everything is all these information are the same, nouns is used to them because I can consequently send 2 bitcoins to Alice 2 times, 3 times. How other in the network can discuss that all these transactions are the same or about the second question, I think The programming part is only the last question. Using EC at first, okay? Send them. Then suppose the signature of a transaction includes the following fields: recipient address, amount, fee, nouns. If recipient address, amount, and nouns, using the generated EC keys, calculate the signature for this transaction. Okay, it's very simple because you use now in this question. At first, you were asked to generate public and private. I have this for my private key. This is my public key. So I can simply use this function to calculate the digital signature. How? By copying this information. Copy, paste it here. Then amount. So amount is 100. Fee is 0 and nouns is 1. Fee is 0, nouns is 1. It's okay. So I think it's enough. And that's it. This is the output. Okay, this is the digital signature. Digital signature. And that's it. Can one want to send? The answer is it's not possible with this part of code, because when you want to send, you need all the network. Okay, all these examples have created hand. Understand? All these information were created by hand. If I want to really send the transaction, I should all the codes. I should use all the networks. We didn't talk about the network. Okay? So it doesn't mean I can create different transactions by hand, but not by code. You know? I can create separately a sender hash, receipt. I can consider, for example, some amount, fee, nouns, and then I can create by the code the digital signatures, and finally I can create the transaction ID. But any code, or at least I didn't give you transactions automatically. Okay? So you can't generate transactions automatically. You should generate them by hand. I think all the necessary codes how to load keys. This is key. This is also for the RSA, the necessary codes to save the keys, to load the keys, also can be as using this command. You can simply save a private key using this one, your public key, and using command you load a public key, or using load public key. This is load public key, but we have load and pulse, so you can use these two libraries to print public keys in SA. But in PC, private key load DR 2 times. We need them 2 times, just one is enough. Using these commands, you can save and load private keys, then using the private generate the public key based on the private key. Okay, but maybe you have some questions in the final. As example 500, based on that calculated, we have some information. Putting at this information, at the end of this information, the resulting hash must started with some zero. The number of zero depends on the difficulty. And example here, the out increase the difficulty. If you want to create a transaction, I'm answering you. If you want to create a transaction, sending some only Bob nouns, they calculate the signature and put the transaction ID. Because the digital signature also can be changed. Okay, prevent others to tamper the transaction for the recipient only the hash. All the in the final exam, for example, and then I find a hash based on to find the nonce that I put the nouns at the end of this information. The resulting hash zeros. So, let me. Okay. Now, as you can see, the output. This is again for the nouns is 24, 31, 81. No, this is not my answer. I'm trying to calculate. I'm trying to find a nation. The resulting hash starts with 4, and this is only 4. So make sure to should be started with 50. The number of bits, yes, the number of bits is now 19. This is the number of bits represented using one character, so it's nearly 20, means that we have 50. So the 5 leading zeros in this example. And so the question you can say, okay, this is the answer, this is the nouns. If you put these nouns at the end of this information, and then if you hash the information with these nouns, the resulting hash will be started. Suppose you are in a reliable environment. In the environment, everybody has a public key and people know the public key of each other. So then how you can send your message in a way that only Ali can read it and can be sure that the sender is you and not others. Suppose, okay. If you can remember, in when started to explain the encryption decryption, at first I talked about the concept of encryption and the concept of digital signature. Okay, if private key by your private key, as you can remember, I said it's not encryption, it's the digital signature, and using this, people can be ensured that the message is received from you. So in this question, at first, encrypt the message using the public key of Ali. So first, I encrypt the message using the public key of Ali, and then I encrypt again the resulted encrypted message with my private key. The network, everybody can decrypt that because only Ali, everybody can check that it's me. Okay, combination is first. The second question, we know in each action there is a field named nouns. Suppose you are not allowed to use instead the same application as nouns. Okay. I think the simplest answer to distinguish between the same transaction, sender, the receiver, the amount, fee, are the same. Okay? If we cannot use nouns, we can simply, okay? So the answer, and I solved all other. Next week, next is the last week. Before the final examination. Please review all the concepts. To arrange all them, and I will have answer your questions. So next week, last session. Okay. Please, all the persons now. Now, if you have any question, please let me know. If you have any question about these two midterm examinations, everything about the course, if to review questions,